G'day Maths Method students. In this video we're going to have a look at how we differentiate the natural logarithmic function. And so the key thing to understand straight away is that the derivative of log e of x is 1 over x. So you can see here that if y equals log e of x, then dy dx equals 1 over x. So when we differentiate log e of something, it's going to have 1 over something in the answer. And for more complicated expressions, we use the chain rule. So this is a more general form of a logarithmic expression. It says if y equals m times log e of f of x, then dy dx will equal m times f dash of x over f of x. So what you can see here is that we're multiplying by the derivative of whatever's inside this bracket, which is f dash of x. The constant that's here at the front stays there in the answer. We're still multiplying by that constant. But whatever's in the bracket sort of ends up on the bottom of the fraction. So we have that 1 over f of x, that 1 over whatever is in here. All right, so let's have a look at a couple of examples, and hopefully this will make sense. Sorry, a bit tongue-tied in this video. So if we're asked to differentiate log e of 5x plus 3, first thing that you would do, or one way you can think of it, if you're applying the chain rule, is that you're just going to multiply by the derivative of the bracket, and the derivative of 5x plus 3 is 5. So it's 5 times, and then it's 1 over whatever was already there, 5x plus 3. Right, and then probably, right, think of that as 5 over 1 times this fraction, you just put the 5 on top. So it's 5 over 5x plus 3. Right, so that's the short way of getting there. As always, if you want to convince yourself, or maybe if it's a trickier problem and you want to just be really sure you've got the right answer, you can always do the chain rule the slow way, which is to let u equal 5x plus 3, and then that will mean that y equals log e of u, and then from these two we get du dx equals 5, because the derivative of u with respect to x would just be the derivative of 5x plus 3, and dy du, so if we're differentiating log e of u, that's just going to be 1 over u, and then when we put that into our chain rule, which says dy dx equals dy du times du dx, well, that's just going to equal dy du, which is 1 over u, times du dx, which is 5, which gives us 5 over u. Sorry, running out of room in my handwriting's getting a bit messy. Gives us 5 over u, which was really 5 over 5x plus 3. Right, so as I said, not necessary to do it this way, but not a bad method to use if the question just looks a bit tricky, and a clear way of showing why this kind of shortcut method of simply multiplying by the derivative and then putting 1 over whatever was in the bracket, why it works out the way it does. So with example 17, the derivative of 3 log e of x to the power of 4 plus 2, well, I would just look at it and go, what's the derivative of the bracket? And the derivative of x to the power of 4 plus 2 is 4x cubed, right? Just multiplying by the power, subtracting 1 from the power, times, now the constant is still going to be there, that 3, right, times 1 over whatever was in the bracket to start with, which is x to the power of 4 plus 2. Okay, and then you sort of tidy it up and you can bring everything together. 4x cubed times 3 is 12x cubed, times that 1 on top, so we can put 12x cubed on top, over x to the power of 4 plus 2. And it's certainly fine to leave your answer like that unless the question's specifically telling you to put it in some other form. Okay, so a couple of exam questions as well, which we'll include in this video. This one's a multiple choice one, and it says the derivative of log e of 2f of x with respect to x is. So this one's kind of going to get us to differentiate something that's got a bit of function notation in it. So probably our calculator won't come in handy here because f of x could really represent anything. But we could say, okay, well, we started before by just differentiating whatever was in the bracket. So the derivative of 2f of x would just be 2f dash of x multiplied by, well, log e of something differentiates to 1 over that thing, so 1 over 2f of x. And if we bring both of those things together, we get 2f dash of x over 2f of x, and those 2's would cancel, so hopefully we've got an option here that's got f dash x over f of x, and yep, we do. It's option A. So don't be put off when you're asked to differentiate something that's got function notation in it. We've just really applied the chain rule and knowing how to differentiate a logarithm to, you know, deal with this question that maybe looked a bit trickier, but actually in some senses was probably easier than dealing with an actual function in here. And last but not least, this is one from an exam 1, and this one says for f of x equals log e of x squared plus 1, find f dash of 2. So we're going to have to find f dash of x and then sub in x equals 2. So read that carefully. Lots of people might just find f dash of x and then stop there. So let's get the derivative first. F dash of x equals, so derivative of the bracket, which is 2x times 1 over what was in the bracket first, so x squared plus 1. Okay, we haven't got, well, we've got a constant here, but it's just 1, so we haven't had to worry about that. If it had like a 5 in front of it, we'd need to keep that in the expression, but not to worry about that here. So that gives us 2x over x squared plus 1 as f dash of x. So f dash of 2 will just be 2 times 2 over 2 squared plus 1. So get 4 on top and 5 on the bottom, so 4/5. Right, so as we said, read the question carefully, not just asking you to find the derivative here, but actually asking you to find the derivative when x equals 2, which is what we've done with that final answer there. That's differentiating logarithms. As always, good luck with your questions and get in touch with your teacher if you need some help. Cheers.